We'll get started here. I'll share my screen and take a look here. So the first thing that it asks for in part C, it says to sort the 10 values from the first row. So you're just looking at the X bar values that you calculated here. All right, and you're just going to put a tally mark for like 4.25 is this one here. 3.5 is the one above it. 5.25 is the next one. 3.5 goes here. 3, you got to be careful when it's right on the edge there. It looks like it's there. 4.75 is there. And then 5 is there. 3.5, 4, and 4.75 there. Okay. And that adds up to 10. There's 10 lines there. So this is 4 out of 10, 4 out of 10, 2 out of 10. And then the others are 0 out of 10.
Okay.
Is that clear for what it's asking for?
Yes.
Literally just counting. Okay, so
Okay.
let's do the same thing for D. Go pretty quickly here. We probably need these numbers for something later on in this. Looks like you're talking about the what is it, the mean? Anyway, think of the word here in a moment. So we're looking at the second row. So
Okay.
I always think it's good to, if you got it, grab a highlighter or something so you know which ones you're looking at. Most errors are made just copying things down. So 4.75, 3.5, 1.5. Well, that's rare. 4.75, 4.5, 4.5, 2.5, 4.75, 3.25, and 2.75. So the teacher's actually, a really good instructor would actually know if you were not doing this at reality, like if you didn't actually do this, because there's a way to look at this and know if you actually did it or not. Or no, and we gotta do the same thing with 20 values extra from the first two. Oh, for the first 2 rows. Okay, I'm so sorry. So we need to add to the whatever we did in the first 2 rows. So it's the one. Well, we didn't have any in the first one. So if we go back up here, you didn't have any here. The second one, it's 2 out of 20. And then this 2 would go with this 4. So it'd be 6 out of 20. Then you got 5 here plus that. So you got 9 out of 20. And then 2 out of 20 for that. Is that okay how we're doing that?
Yeah.
Okay. Because then it looks like we have to do the same thing with all 40 values now. Okay. Let's see what they're doing. Let me grab this table again. And this time we're looking at the last 2 rows. And we're going to combine those with the previous numbers, but we'll do them one at a time here. One row at a time, I mean. Let me snip in the table for E. Okay, so we're I'm just going to do the tallies here again. So 5.25, 4.25, 5, 3.75, 4.5, 3.5, 4.25, 3, 4.75, 4.75 again, 4.5, 4.75, 3, 2.75, 5, 2, 2.75, 3, and 2.5. 4, 8, 10, 16. Did I miss? I might have missed one here. 4, 8, 10. No, I didn't. Okay. Yeah, that's right. All right. So the idea is you take these occurrences 4, 6, 7, and 3, and you add them to the previous ones. So the previous one here was 1 out of 20. So it's now 1 out of 40 because none combined with it. That 4 goes with the 2 out of 20. That's 6 out of 40. 6 goes with the 6 out of 20. So that's 12 out of 20 or out of 40. Sorry. The 7 goes with the 9. So that's 16 out of 40. And then the 3 goes with the 2. So that's 5 out of 40. And these should all add up to 40, and they do.
Okay.
Any questions on that or any follow-up from that page?
No, not so far.
Normally you would just go right to E, like you would never do B, C, or C, D, C, and D. You would just look at the table and just count them up and put them in the table.
Mm-hmm.
You wouldn't do anything else with that. Okay, so we're going on to number 2 now. Is that right?
Yes.
Okay. So let me see here if I can rotate this picture. I cannot. Let me download it. Got it. Okay. Do the same thing again. All right. So we're going back. We're going back to the first 10 values.
Mhm.
And I'm going to grab a snip of this because we need it for the histogram. So I'm going to grab that. Okay, so there's that. And then if I grab the 2A graph, it's a histogram bar graph of these. So you can convert the, actually, let me make this bigger. It's fine. You can go instead of 0 out of 10. Well, that's not, I mean, that's 0. But 4 out of 10, you can think of that as 0.4, 4 out of 10, 0.4, and 0.2. And so those are the heights that you need. So from 0 to 1, it's right there. There's your line. 1 to 2 is 0. 2 to 3, I'm sorry. We don't have anything it's from 1 to 2, and then 2 to 3. From 3 to 4, it's 0.4. So you go up to wherever you kind of feel like 0.4 is. You do that. 4 to 5 is also 0.4. So it should be right there. And then 5 to 6 is 0.2. So roughly there, like that. In a histogram, the bars touch. It's a small thing, but
Okay.
so for the next graph, first 20, we have to do the same thing. So I got to go back and grab the first 20 here. And let me grab a snip of that. Can you remember a day it rained as much as it did today?
No, not in a while.
So that's incredible.
Yeah.
All right, so first 20 values here. So yeah, again, if you need to go to calculator, 1 out of 20, you can think about a 20 as 5s. So the 1 is 0.05, 2 out of 20 is 2 of the 0.5s, so that's 0.1, 0.6, 6.5s or 0.3, 9 is 0.45, and 2 is 0.1. So this one I have a little bit more going on here with it. So from 1 to 2, it's 0.05. From 2 to 20 is 2 to 3 is 0.1. 3 to 4 is 0.3. 4 to 5 is 0.45. And 2, and the last one here is 0.1. Something like that. Let me know when you get all this down and move on. Excuse me.
Okay. Okay.
Okay, so now we got to grab the, having a technology thing here. Come on. All right, I got to grab the last, the final one there. The part E, grab this. Okay, so when it's out of 40, you can think of to get from 40 to 100 as 2.5 times 2.5, if you don't have a calculator handy. These ones, you know, they're not as nice as the other ones, but it's 0.025, 0.15 for the 6, 0.3 for the 12, 32, 38. Am I struggling? I may have to go to the calculator. 40.4. And then for the last one, it is 0.125. And you need these to be able to do the graph. You can't get the heights without it.
Okay.
All right, so here we go. So the first one there from 1 to 2 is 0.025. So it's kind of right between the 0.05, 0 and the 0.05. So that one's right nestled in between there, kind of hard to see. 6 out of 40 is 0.15. That's a nice one. It's nice when the computer does this for you, and most software packages do that. 12 out of 40 is the 0.3. And then the next one here, the 16 out of 40 is 0.4. And then the last one, 5 out of 40, 0.125, kind of somewhere in there for that. Let me know when you get all that down. We can talk about number 3.
Okay, I think I'm good.
Okay. All right, so number 3 says to comment on the different shapes of the graphs here. So let me just spend just a tiny bit of time here to grab the 3 graphs so we can talk about them together. So they're all in the same window. Here's the first one. Okay, here's the second one. You don't have to regraph them, but I want to show them together to help make it clear.
Okay.
Okay, so here are the 3 graphs, kind of side by side. So if I draw like a kind of my best guess of what the shape of the distribution looks like based on these, here is one. And this other one is there. And then this other one is kind of like that. Well, it's not great. I mean, it's probably more, it's really goes like that. And I don't know if you can see this, but these are all heavily what is called left-tailed. or negatively skewed.
Mm-hmm.
Let me draw a proper negatively skewed one so you can see it. It's got a really long tail, comes up, and then it doesn't have much of a tail on the other side. It's not so good. Let me try that again. Something like that. So there's much more of a tail
Mm-hmm.
on the left. The other thing that you would want to say is that so here's what's supposed to happen. The more you do this, the more the actual graph is supposed to look like this,
Mm-hmm.
a normal distribution. Now, when you take data in real life, it doesn't always work out that way, but it like rolling a dice is fairly predictable. But you're supposed to get that, and that leads to number 4. Okay, and the word I was thinking of that is the central limit theorem. Maybe you heard that in class.
I have not.
You've not. Okay. So number 4, what you're supposed to say here is that what you predict is that it will the histogram will look more like a normal distribution. In other words, it will no longer be skewed.
Okay.
And that is what is referred to as the central limit theorem. But you said you haven't covered it yet, so I won't say any more on that. Do you have any other data from another group, or do we want to make it up here?
I don't know. With
Okay.
another, does that mean like
Another so another group of people that have this 40.
Oh, I guess it's fine that we can just make something up.
Okay. Let me be careful here. Let me grab these numbers. And then to kind of make it what we want it to look like. All right. Okay, so we want to say so the correct answer is supposed to be 3.5. Is what it's supposed to be when you do this a million billion times. So that we have to get that to be more. So let's go. Make these numbers nice. Let's go 2 out of 80. 10. So 10 out of 80. And then let's go 30 out of 80. That's 42. And then we'll go 24 out of 80. That gets us to 76. That's probably not quite. It's probably too big. Let's change that to 22 out of 80. So that gets you to 68. And then that'll be 12 out of 80. That's somewhat reasonable here. Okay, so the 2 out of 80 is 0.025. And I'm going to a calculator for these. These are hard to do by hand. 0.125. 30 out of 80 is 0.375. 22 out of 80 is 0.275. And then 12 out of 80 is 0.15. Okay, so we'll just graph these here. So the 0.025 is like that. 0.125 is like that. And then 0.375 is up here a little ways. 0.275 is kind of there. 0.15 is kind of there. And the idea here is that this has more of the normal, closer to the normal distribution.
Mhm.
Is the idea. That's what the instructor would be saying. Say, look, and if we combine everyone's data, we get something that's even more like the normal distribution. But that's it. I mean, that's everything for that particular problem.
Okay.
Okay, so your next page here on the uniform distribution, it's completely accurate.
Okay.
All right. Are you graded on this? Because I would give you a different example for a uniform distribution if you are.
It is graded. I kind of just didn't really know what to say. I just kind of wrote something down.
Well, how would you know? You don't you don't know distributions. It's ridiculous to ask you something like this.
Yeah.
So uniform, the thing that you should take away from uniform is that it's the same probability for each event.
Okay.
Okay, so like you have to think of something, and the most simple one is like a coin flip. Okay, it's you either get heads or tails. It's the same probability for each event. Okay, but that's not a great one for this. If you don't want to get very creative, you could say drawing numbers out of a hat.
Okay.
That are numbered, that are 1, 2, 3, and 4, and you just like you would have the number of ones is 0.25. The number of getting a 2 is 0.25, getting a 3 is 0.25, and so on. And it's kind of what you were trying to say here in your example, but the one I gave will be more acceptable.
Yeah.
It's kind of like you don't want them to think real hard about, like what you've got down there.
Okay.
Okay, so lots of time left. What else can we work on tonight? Do you have some other things you can send over?
That's pretty much it for all the material I have. So I don't really know.
Yeah, I mean, we have some options for the rest of the time. I can make up questions like the ones you're doing here. We can do SAT prep. We can do nothing. It's totally up to you what you want to do at this point with the time.
Can we do some SAT prep, please?
Sure. All right. So let me, so I know you weren't able to join me on Saturday for the preview class. And if you have not watched that video, I'd like to run through some of those problems with you. If that's okay.
Yeah.
Perfect. Let me get those up here. We may have done some of these. I did try to, I'm always trying to pick new problems because I try to pick ones that are interesting to me as well,
Mhm.
because it helps. But go ahead and take a look at this one and let me know what you come up with for your final answer.
Is it C8?
Yes, it is. It is 8. So the approach that I would tell you to take here is to always look at that last sentence first. How many teaspoons should the patient take in 24-hour period? And they tell you that they take it every 6 hours. So it's like 2 teaspoons, 6 hours, and then 24 hours is what I care about. Like the problem could have said 12 hours or could have said 18 or 30, we don't know. But how do I go to that and multiply by 4? So I multiply this by 4 to get 8. So some variation of that would be wonderful. But the next problem, I'm actually going to give it to you without the multiple choice because you're too good with the multiple choices there. Want you to see if you can work it out without that. And then we'll
Okay.
talk about a couple of ways to do it otherwise. Okay, so here's a sample problem here. So it says if x plus 3 equals 2x minus 2, what is the value of x minus 4? So notice they're not asking for x, they're asking for x minus 4. And there's a couple ways to do this. Kind of the direct way is probably what you'll do, which is where you solve this equation on the left for x, but there is another approach to look at. So go ahead and take a look at this one. Let me know what you come up with, please.
Um, the value of x minus 4 is 1.
That is correct. Okay, so we know the answer is 1. You probably solve for x and then subtract it by 4. But the kind of the better approach here is to manipulate this thing into getting x minus 4 on one side. And you might be thinking, what do you mean by that? Well, if I subtract x from both sides, I now have x minus 2 on the right. How do I get minus 4 on the right? Well, I can subtract 2 from both sides. And you would never do this in the classroom, right? This is insane. But in the SAT, you would do something like this. So you actually manipulate the equation to make it into what you want.
Okay.
Okay, so if you're willing, I'd like to give you another problem to try like this and see if you can try this approach that I'm talking about here. Like it may seem silly, like why would I ever do that? Well, these are questions that you can get faster at by doing it this way. All right. So did you follow what I did here? I was trying to make one side or the other look like x minus 4. After I subtracted x on both sides, I realized, oh, it's minus 2. So I can subtract 2 from it to get, but I got to do it to both sides. Maybe, yes, no.
I think I kind of know it where I think I could do it on my own.
Okay, let's try one here. Okay, if 5x plus 4 equals 4x plus 7, what is x plus 3? If you have any questions, please ask.
I think the answer is 6.
Okay. So your answer is 6. I don't know. I haven't looked at this yet. I subtracted 4x from both sides. Is that what you did?
Yes.
Okay. So on the left here, I've got x plus 4 equals 7. And I really want x plus 3, so I'm going to subtract 1 from both sides. So yeah, x is 6. Good. The other kind of variation on this that we saw is like when you solve for a multiple of x, which we don't need to do, but it's odd. It's just something you would see in a test like this one. Actually, before I do that, like I think the most important thing I covered are the test dates. Do you know all the upcoming test dates? Because I'll just snip them in real quick if you don't believe these are still accurate. So ACT is the big one. It's got a late deadline of January 20th if you're going to sign up for the February 11th test. I don't know if you're still in line for that one, but SAT is out until March 11th. So just keep that in mind. You don't have those on your calendar. Please sign up. All right. So here's a problem where you do need a formula potentially. Okay. It says in the XY plane, a circle with radius 2 has center 0, 0. Which of the following is an equation of the circle? So it really helps if you know the equation of the circle. Are there 2 answers that you can eliminate because they are not the equation of a circle here?
I'm trying to remember what the.
Okay, yeah, I want. So here's the general form, which you do not need to know. Like this is not on there, because they generally keep it pretty simple. They say, oh, it's a radius. It's got center 0, 0. That's h and k. So that means when h is 0, it's x squared. When k is 0, it's y squared. So see the plus? That gets rid of c and d. And that's key here. That's that's the big deal about this problem. If you can do that, you get it down to 2 answers, and all of a sudden, you know, if you're guessing, you're much better off here.
Yeah.
Okay, so do you remember this part on the right here, the r squared?
Yes.
So that means you take your radius and you square it. So which of these 2 would be the right answer based on that?
Letter B.
Yes. 2 squared is 4, letter B. You got it. But so here's another thing. If you could have gotten it down to B and D because you knew the radius or the radius was squared, that's also better. You know, that's a better, another way to guess between those 2.
Okay.
All right, so here, let's look at another question. So I'll give you the question in a moment, but let's say I tell you that f of x minus 2, I write that, and then I tell you that we want the value of f of 1. Let's say we want to find f of 1. Okay. So what I'm asking, what I'm trying to do here is get you to think about what value of x when you subtract 2 gives you 1.
3.
Yeah, when x is 3, you get 1. Okay. So if the problem, like let's say f of x minus 2 was x squared, and I wanted f of 1, what value is going in for x?
3.
3, because 3 minus 2 gives you the 1. That's what's going in here. That's what you're finding. And it's odd, right? It's like, why don't I just put 1 in there? Because that's not x. X is 3. 3 minus 2 is 1. That's the value that goes in for x.
Okay.
Okay. Is this okay? Are you ready for the problem, or do you want another one like this?
Can we do one more example, please?
Sure. Let's say it's f of x plus 4 equals 2x minus 5. And I want f of 2. So what x value makes it now 2 inside parentheses?
-2.
Yes, x is -2. Okay, so when you're evaluating this, you're putting -2 in for x.
Okay.
That's -4 minus 5, which is -9.
Okay.
Let's try one more. Let's say it's f of x plus 1 equals 4x plus 7, and I want f of -3. Do you have a question for me? Do you have an answer?
I'm almost done.
Okay.
The value for x, I got -4, and then once I plugged it in, I got -5.
4 times -4 plus 7. I think you made an arithmetic mistake. Not sure where though. This
Oh,
is
okay.
That's okay. We've got one more. We got the real one. It's an odd question. It's, if you see it, now you know how to do it. It serves no purpose other than this. So here's the real question. Okay. And I pointed this out for the students class. I said, you don't just put -3 in for x,
Mhm.
because that's not the value of x. Okay. You have to do just like we did. If you figure out what value of x makes it -3, and that's the number that goes in for x.
Okay.
So take a moment, see what you come up with, and let me know your final answer, please.
I got -2 for x, and then for the final value, I got -1.
You are correct.
Okay.
Fantastic. Good. Okay, so when you know how to do a problem, that's why we practice. Like it's like all this leads up to like one question and one exam at one time, but that's why we're doing it. You will
Mhm.
never see a problem like this again. I mean, you're going, hopefully you get admitted to the Naval Academy, and it's like they're not going to ask you this. I mean, I hope
Yeah.
not. Really hope not. Hope you guys are doing some other things that are more important here. So, new question. This is one where it appears to be symbolic. It's like, okay, the graph y equals mx plus b, m and b are the constants. You know that m is the slope. You know that b is the y-intercept. Okay, it's showing the xy plane. But what does it ask you for? What is the question? And that's why I always say to start with the question first, the thing that it's asking for, the call to action. What does it want?
The value of m.
Or the slope?
Okay.
And I know you don't have, I know you don't have this like printed in front of you, but I would tell you to literally count, rise, run, however you want to do it. Do not use the slope formula. So whereas like 2 problems ago, it's like, yeah, you need the equation of a circle to do it. This one, you do not need the slope formula. You just need to know the rise over the run. And could you tell me what that is here for your final answer?
2/1.
2/1, good, or 2. Good. Okay, so before we do the next question, I want you to think about, I want you to tell me what this results in. If I just said to expand or multiply, can you tell me what the result of this would be? You can work it out if you need to on your own.
I got x² plus 2x plus 1.
Perfect. Okay. Now I'll do the one in the middle here. This one is x² minus 2x plus 1. And then this last one I want you to think about, or FOIL for me. I'd like you to do this last one on the right here. What does this reduce to when you're all done?
X² minus 1.
Okay, so now I want you to answer this question. How many terms, it's for each one, how many terms each? How many terms does this first one have?
3.
3, and then the middle one,
3.
and then the one on the right,
2.
2. So whenever you have something in this form, x plus 1 squared, x minus 1 squared, they always have 3 terms. Like if it was like 5x minus 12 squared, it's still 3 terms. Or 4x minus 8, it's still 3 terms.
Mhm.
The only time it goes down is when they're opposite, like when it's 1 minus and 1 plus. Okay, so there's a reason I'm bringing that up here. I don't have, actually, let me go, I can do this real quick here. We're almost out of time. Well, I want you to look at the answers here of this problem. And think about what I just said in terms of the number of terms. What do you notice that's different about each of these? Like
Um,
how many terms do A and B have?
3.
A and B have 2 terms.
Oh, 2. Okay.
Okay, and but C and D have 1, 2, and 3 terms.
Mm-hmm.
Okay, now let's look at the actual question. Okay, here's the actual question. It says, which of the following is equivalent to A plus B over 2 squared? So how many terms does the answer have for sure?
2.
2. 2. No, no. Uh, oh, I thought I let you talk me into that. We just did one like it. X plus 1 squared is like the A plus B over 2 squared. So see how the X plus 1 squared had 3 terms?
Mm-hmm.
So this thing has this thing right here on the right, it has 3 terms. So A and B are out.
Okay.
Okay. Now maybe that didn't make sense. I tried. It tried something different. I don't think it worked out as well this time. But here's what you don't want to do. You don't want to FOIL this. Okay. And here's why. When you look at C and D now, what are the differences between C and D?
The second value isn't divided by 2.
Second term. What about the third term?
D is like the third term in D is divided by 4 instead of 2.
Okay. Now, if we go back to the ones that you were doing, when you did X plus 1 times X plus 1, how do you get the last number?
You do the last term, so you multiply the last 2 numbers together.
And same thing here, X minus 1, X minus 1.
Uh-huh.
You multiply the last two together. So to get the last term, you don't need to FOIL this. You just need to multiply B over 2 times B over 2.
Okay.
So which one does that become? Is it B squared over 2 or B squared over 4?
It's B squared over 4.
Yes. Very good. All right. Let me real quick here. Stop recording.